Hey everybody, this video is for lesson 6.4, solving radical equations, and this is the day 2 video. If you have not watched the day 1 video, I suggest that you do that first and then come back to this one. So the first thing we're going to start with is kind of a real world problem based on what we learned last time, which is solving radicals that have roots in them, or solving equations that have radicals or roots in them. So this is just a real world example. This could be a word problem that you could even see like in your physics class if you're in physics, dealing with pressures. All right, so in a hurricane, the mean sustained wind velocity V, so that's our velocity V, and that's in meters per second, can be modeled by the equation V of P. So V is dependent on air pressure P, and that's equal to 6.3 times the square root of 1013 minus P. Again, where P is the air pressure in millibars, and that's at the center of the hurricane. So we want to estimate the air pressure. So again, we want to estimate P at the center of the hurricane when the mean sustained wind velocity is equal to 54.5 meters per second. So this is a simple plug in what we know, solve for what we don't know type equation. All right, so we know that the wind velocity is 54.5, so I'm going to plug that in instead of V. So I'm going to have 54.5 is equal to 6.3. Draw that 3 a little better here. 6.3 times the square root of 1013 minus P. Now notice that we have decimals in our original problem, so we are expecting to have decimals in our solution as well. And so we will be just plugging things into the calculator and getting decimal solutions. So the very first thing I want to do is isolate the radical. And what's messing that up right now is the 6.3 being multiplied by the radical. So I'm going to divide both sides by 6.3 in order to get rid of that. That gives me 8.65. And notice that I took that to one more decimal place. That's kind of common when if you're going to round it. You can just leave this whole thing in your calculator if you want, but it'll help you maintain your accuracy as we go along. And so we've gotten rid of the 6.3s and we want to continue solving. Well, now we have the radical isolated. So we can get rid of a square root by squaring. So a second root by taking the second power, and we have to do that to both sides. So we get 74.84 on this side. And when we cancel the second root and second power, we're left with 1013 minus P on this side. And now we continue solving. We're trying to solve for P, so we need to get rid of the 1013 by subtracting it from both sides. That's going to leave me negative 938.16 is equal to negative P. I want positive P, so I'm going to multiply through by a negative 1, or you can just think of it as canceling the negatives on both sides. And that's going to leave me with P is equal to 938.16, and my units on that is millibars of pressure. So that's just one way that a equation with a root can be used in a real world situation. The rest of the time today, what we're going to spend our time on is some examples looking at using properties of exponents to solve problems. So instead of having radical form, we're going to be writing equations in exponent form and solving them. Remember that you can always move between radical and exponent form using your properties of exponents that are on your blue sheet in class, or in your notes for 6.1 as well. So we're going to solve using properties of exponents. And the one in particular that we're going to be using today is the power of a power, which says that if we have a base A and it's raised to the m power, and then we raise that entire thing to the n power, we are in effect multiplying the two exponents, the m and the n, together to get the power to a power. So let's take a look at an example where we use that to solve an equation. So example number 2, by the way, the word problem is example number 1 if you didn't pick that up. We're going to have 2x to the 3/4 power plus 2 is equal to 10. Just the same as we did last time when we isolated the radical before continuing to solve. This time we want to isolate the term that has the exponent in it before we continue to solve. So I'm going to switch colors here to make it clear where my solution begins from my original problem, and subtract 2. All right, so I'm going to subtract 2 from both sides, leaving me with 2x to the 3/4 power is equal to 8. And now I have my exponent isolated, which is what I wanted. All right, so I told you we were going to be using our power to a power in order to solve this. And so we want to be strategic or smart about what kind of a power we raise this to now. And if we were going to multiply things together and we want to make the power disappear, the exponent disappear, and the exponent is the 3/4, the way we could do that is by multiplying by its reciprocal. Okay, if we multiply by the reciprocal, then we have a 3 on the top and a 3 on the bottom, and those will cancel to 1. We also have a 4 on the top and a 4 on the bottom, and those will cancel to 1. So our overall exponent is just 1 at that point. So just to be clear, I'm going to come over here on the right. We started with an exponent of 3/4, and we want to multiply it by something that's going to give me an answer of 1. I want an exponent of 1 because I want the exponent to just completely disappear. And an exponent of 1 is the same as not writing an exponent. So if I multiply this by 4/3, my 3's cancel and my 4's cancel, and I'm left with just a 1. So that's how we're going to negate or take the opposite of an exponent. So again, just like the root and the power canceled each other out this last time in the lesson, our exponent and reciprocal exponent are going to cancel. So I'll be left with 2x on the left-hand side, and x to the 4/3, if you put that in your calculator, is 16. And then just continue solving, leaving me with x equals 8. Just like the last time, we have to check our work and make sure that this is truly a solution, or see if it may be an extraneous solution. So let's plug in 2 times 8 to the 3/4 power plus 2 is equal to 10. 16 to the 3/4 power, which if you put that in your calculator is 8, plus 2 equals 10, and yes, 10 is equal to 10, so we are good, and we can box this as an answer. All right, before we go further, let's just kind of go back and write down the steps that we just did in order to solve. That way you can refer back to this for other problems. So the first thing we did was we isolate the term containing the exponent. And in order to do that, we may have to add or subtract or multiply or divide if needed. In this example that we just did, we had to subtract. We had to subtract 2 from both sides to isolate the exponent term. Once we do that, then we eliminate the exponent. And we eliminate by raising both sides of the equation to the reciprocal exponent. So remember, reciprocal just means flip the exponent. So reciprocal exponent. All right, after we do that, we just continue solving and check our answer. The check, again, just like last time, is an important part. You cannot skip that part. All right, let's look at another example. So this will be example 3, and we're going to have x plus 30 to the 1/2 power is equal to x. So this time we have x's on both sides. So this is kind of a second level problem where we're taking it up a notch by having x's on both sides. All right, looking at this, the term with the exponent in it is the only thing on the left-hand side. So I'm ready to just go straight to multiplying by the reciprocal. The reciprocal of 1 over 2 is 2 over 1. Technically, you could just write this as a 2, but I'm emphasizing that it's a reciprocal for now by writing it as 2 over 1. The exponents cancel, leaving me with x plus 30. And then on this side, I have x to the 2 over 1 power, or just x squared. Again, we don't have to write that 1 on the denominator. All right, this is looking very much like some of the problems we solved last time now. I want to get everything on one side so that I can use an x puzzle. So I'm going to have 0 equal to x squared minus x minus 30, and pull in a little x puzzle of negative 30 for the terms to multiply to, and negative 1 for them to add to. And that's negative 6 and 5. So we can write our factored form as x minus 6 and x plus 5 is equal to 0. And then solving the two little algebra equations, x minus 6 equals 0 gives me an x of 6. X plus 5 equals 0 gives me x equals negative 5. And those are my two apparent solutions, but now I need to check them and see if they truly are both solutions. So here's our check. All right, so plugging back in with 6 into my original equation, I have 6 plus 30 to the 1/2 power is equal to 6. 36 to the 1/2 power is equal to 6. 36 to the 1/2 power is the same thing as square root of 36, which is 6. And so this is good, and I can box x equals 6 as a true final answer. Now let's check with negative 5. So negative 5 plus 30 to the 1/2 power is equal to negative 5. 25 to the 1/2 power is negative 5, and if you take 25 to the 1/2 power, or same thing as square root of 25, you're going to get 5. 5 is not equal to negative 5, so this one's no good, and we cross it out as an extraneous solution. All right, so that's example number 3. Let's do one more, just to make sure that you got this solidified. So example number 4, x plus 12 to the 1/2 power minus x is equal to 0. All right, so the first thing we want to do is isolate the term that has the exponent on it. And so we need to add x to both sides to get that from the left to the right, leaving me with x plus 12 to the 1/2 is equal to x. And now we're ready to multiply by the reciprocal. Again, this time the reciprocal is still going to be 2 over 1, which will cancel because it becomes an exponent of 1. And we're left with x plus 12 is equal to x squared. The problem kind of works out the same way as the last one at this point. We're going to subtract x and subtract 12 from both sides, leaving you a 0 on the left and x squared minus x minus 12 on the right, and we're ready for an x puzzle. Factors of negative 12 that add to negative 1. That would be a negative 4 and a 3. So we can write this in factored form as x minus 4 times x plus 3 equals 0, or x equals 4 and x equals negative 3. All right, so those are our potential solutions, but we must check them and see. So let's check by plugging in 4 to our original equation, giving us 4 plus 12 to the 1/2 power equals 4, or 16 to the 1/2 power equals 4. And so that is a good solution. The square root of 16 is 4, and so that's true. All right, now let's plug in negative 3. So negative 3 plus 12 to the 1/2 power is equal to negative 3. 9 to the 1/2 power is equal to negative 3. But 9 to the 1/2 power, or a square root of 9, is a positive 3. Positive 3 is not equal to negative 3, so this one's no good, and we must cross it out as an extraneous solution. So anytime you're working on homework, classwork, a quiz, whatever it may be sure you are very clear in indicating that you know which solutions are true solutions by boxing them or circling them or some other form, and crossing out the ones that are not true solutions, that are extraneous solutions, because they gave you a false statement. 3 is not equal to negative 3 in this case. So please be sure that you have made that clear so that I know that you know what the true answers and the extraneous solutions are. All right, that's it for today. Thanks.